sincerely, Mr. Ryan, alright? Yes, okay. So we have a rod or rope or whatever, a stick, yeah? Yeah, basically the straight thing. And we know the length, which is n. This is the integer, positive integer, right? So we want to cut it. Yeah, we know we want to cut it and sell it. Yeah, we want to cut it and sell it. So, for example, like if we have this, we have this array, prices array, okay, prices array, which is 1, 3, 5, 7, 7, right? Let's see. Okay, so it means that if we cut the row, if we cut a rod, okay, let's call it rod. If you cut a rod with size 1, we can sell it at $1. Size 2, $3. Size 3, $5. Okay, cool. Okay, so look, this is I, right? So basically, price I means that we can sell the size with size I plus 1, right? Why I plus 1? Because I is the index. The first element is 0, okay? So if the n equals 6, right? If n equals 6, how can we cut the rod so that we sell the maximum profit? So for example, 6, I can cut it with 1 plus 5, right? So in this case, I will sell what? 1 plus 7, yeah? Yeah? Got it? That's size 1, 2, 3, 4, 5. So 1 plus 7, right? So that's 8. But if I cut it into 3 plus 3, so 1, 2, 3 here, so I could sell it with 10. So this is bigger, right? Or I can cut it with 2 plus 4, so I could sell it with
2 plus 5.
2 plus 4, 6, n equals 6. So I could say it was $3 for the size 2.
So you don't
and
number
for,
it can make
for the,
it
yeah.
6.
So that would be 2 plus.
So the only number that
Sorry?
that could only be 6.
Why it could be on 6?
Could only be 6.
Hmm? Do you get this problem?
No.
No, not really. Okay, so if we,
Kind of.
sorry?
I get it kind of.
You get it kind of, okay. So look, if we set it with that, if n equals 6, then we can split it into 2 and 4. 2 for 2 would be $3. For 4 would be $7. So 3 plus 7 is also 10, right? Any other options like 1, 5, 3, 3, 2, 2, 4. Okay, this is only options, right? Okay? Make sense?
Mm-hmm.
So how so what's your approach of doing this? What's your approach? Think about it.
Okay, so you just see that price and write other thing up to the n.
That's right, yes.
And then like 1, 2, 3, 4, 5 and or 6.
Yeah.
And then like if it says that, and then you try out every possibility. Like if
Yeah.
1 is 1 plus 5, you check out 1, and then okay, 5 is 7.
Well done. I know you. So we tried every possibilities. Yeah. We see. Look, this is the integer. So we talk about how to split the integer before, right? So if we have this fn, which is the integer, right? We can split this n, right? We can use depth search, breadth search, right? Yeah. To do it, right? So we can try with 1. Okay, so 1. I split it to 1. I calculate this. So we have this function depth search with this current. With the remaining n, right? And then with this current profit, right? With the current profit. And what else do we need? And we can just look it up, right? So let us just quickly write the pseudocode for the depth search. Right?
And then
Yeah.
the search.
So look. Actually, depth search n, right? So we don't need the let profit thing. Define. Okay. So we want to find out the maximum, right? So we will have a maximum maximum perfect here, right? So let's say maximum perfect. At the beginning is 0, right? Yeah? Yeah, maximum perfect. Then we can look at this, we want to find out this n. We want to cut this n, right? Cut this n. So we can try every possibility. So at the beginning, for I in range, right? For this n, I can cut it or not cut it, right? Alright? Yeah? So for this I equal range, let's say what? So I want to try, look, for this n, I can try with up to n plus 1, right? Up to n plus 1. Yeah? And then I can cut it. How can I cut it? How can I cut it? dfsi. Right? We can dfsi. Actually, no, dfs n minus I plus price. So now I can have this price I for I, right? Price I. But n minus I minus 1, right? Because I starts from 0. Right? Yeah? Yeah, makes sense? Now I have this answer would be at the beginning would be max dot infinity. And then this answer will be the mean of this answer and then this bit. Right? And I just need to return answer. Alright? Okay, so now here I need to check if n is smaller or equal than 0, return 0, right? Right? Yeah? So what's the problem with this one?
It's slow.
Why is it too slow? Actually, because n price is okay. So this index starts from 0 to n minus 1. So but the actual size it represents is 1 to n, right? So it needs to plus 1. So this is n, and then needs to n minus I minus the price I, right? Right? Look. Yeah. So look. I try every possibility for currently the rod size is n, right? So the rod size is n. How many possibilities of cutting this? I have this, for example, the n equals 3. How many possibilities of cutting 3? N equals 3. 0, 1, 2, 3. How many possibilities?
6. No.
The n equals 3. N equals 3. The size there are 3. How many ways of cutting it? Come on. I can cut is 1 to 2, right? Or I can cut it into 2 to 1, right?
2.
Or I can cut it with 0.
Sorry.
Yeah, is this 3? Yeah. So look, I cut 3 ways. Cut it with 3. If I don't cut it, okay, so look, if n equals 3 here, I is from 0 to 2, right? I is from 0 to 2, so price would be from 0 to 2. Oh, so, okay, yeah, I don't cut it, actually, if I don't cut it, the size would be remaining the 3, right? Right? Got it? If I equals 2, if 2, then n minus 2 minus 1. Okay, so then the remaining will be n minus 3. Yeah? Okay, that makes sense. Make sense? Okay, so look, what's this? Look, I have a rod with size n, right? Yeah, this is basic. So I can try cutting with the 1, cutting with 2, cutting with 3. Look, if I cutting with I, right? With cutting with the size I. Okay, look, if I cutting with the size I, actually is I plus 1. The size here is I plus 1, okay? Okay, so what's here? What's remaining here? If this is I plus 1, what's here? The whole thing is n. If this is I plus 1, what's here?
N minus I plus 1.
Plus?
No, I minus.
I. What? This is I plus 1. N minus I
I
plus
minus 1.
minus 1, right? So this bit is okay. So if I want to keep a size with I plus 1, so this bit I can get a profit of what? Price I, right? Yeah, this is known, right? Yeah? Okay? This bit is known, yeah? And what's this bit? What's this bit? What's the price for getting that?
N minus I minus
This is the size.
N minus I.
So, but we are not sure how many cuts for these, right? So then we can call this DFS function to solve the problem with the smaller size, right? Yeah. So that's what this part is about. You see? Yeah. And then I can do this with answers and compare with the get the minimum. Okay. What's the problem of this approach, depth search? Okay. If I tell you that. If I tell you that there's an easy way to make a depth search, the proof of thing, depth search, into a dynamic programming, and you have used this before, so what would it be? If I tell you an easy way, there's an easy way between this approach. If I add something here, that will become a top-down dynamic programming. What's the problem of this?
It'll be explanation of.
Because we calculate.
Cache.
Yeah, we can even put a cache here, right?
Oh yeah.
Wait then, okay. Make sense?
Oh yeah.
Yeah. Okay.
Oh yeah.
Okay, can you explain to me?
An egg.
Sorry?
Nothing.
What's this bit?
Which bit?
This bit, depth search, n minus I minus 1. Can you explain to me?
Okay, so we know this is I plus 1, and we can cut it, and this is n minus I minus 1, but it hasn't been cut, so depth search is just gonna cut.
Okay, so you kind of, I understand right now, but yeah. Okay, so so we are trying every possibility for this size n. Yeah, we can try, keep a size keep a fixed size, right? We want to sell the size first part of these, yeah, and then I get the profit price is I, right? And then when I keep a size I plus 1, and I have the remaining size. So then I can call this function recursively, call this function depth search, yeah, to find out, to compute the profit I can make. The profit I can make by cutting. At this point we are not sure the best optimum way of cutting that. There will be no cut or there will be many cuts, but we don't know. But we call this function to recursively find it out, right? Yeah? Look, this answer at the beginning is max infinity, and we're getting the minimum. We compare the minimum, right? And this part is for I already made the decision, I. So this part I make the decision. So every time I make a little decision, right? Look, this whole rod, I don't know how many cuts I want, right? That would be too complicated to consider all these, right? But what should I do now? I can try. Okay, let's make a little decision. What is that? I can make a decision. Okay, I can cut the size with 1. Yeah, I can keep a size with 1. I can keep a size with 2. I can keep a size with 3. Right? So I can keep size with this I. And once I keep a size with I, then I know the profit I made from cutting this bit, right? Right? Yeah? And then I can keep doing this, right? Make sense? And this is explanation without the cache, right? Remember, DFSN is the maximum profit if we can share the rope with the size n, right? And then I'm iterating all possibilities of cutting the size n with the first cut I. When I first cut the size with the first cut I have remaining n minus I minus 1. Right? And then I look, this is the smaller size with n, right? This is smaller than n, right? You see, if this is smaller with n, and I can recursively calling this function to solve a smaller problem, right? Eventually, I can look. I need to put this if n smaller than 0. If n is 0, the base case is right. Too noisy. If the n is 0, means that The size is 0. What's that? I can sell empty. I can sell air. What for nothing. So what's the price of selling nothing?
0.
Well done, 0. Right? Got it? What do we call this? Dynamic programming. What kind of dynamic programming is this? Top down or bottom? Top down, yeah? Is it top down?
Yes.
Okay, this is the top down dynamic programming. So tomorrow we'll talk about bottom up, okay?
Yeah.
Yeah, and what's the time complexity and space complexity?
O-N.
For look at their n.
O-2-N.
Look at their n. N, right? But for each one I have to do this.
O-N square.
Yeah, O n square. But the space complexity,
O-1.
I have a cache. Why is the O1? What's the space complexity?
O-N.
Eric, Ryan? Anyone? One final answer. What's the space complexity? Look at that n. I put a cache. How many states I need to store? Need to cache?
2.
2? What 2? Look at this n. If n is 100, how many values of DFS n I need to store?
100.
Yeah, 100. And what's that? O n. Yes, well done.
I literally said that right.
Yeah, I know O n. Look at that. But the space is the time is O n squared. Why is that? For each n, I need to iterate with n, right? Got it? Okay. Okay, that's it for today. Bye bye.